information and analytical support for technical monitoring systems with a multi-level structure. In the field of research into multi-level monitoring and diagnostic system for complex technical objects, particularly for mass service system, there has been active development of both applied and theoretical approaches in recent years. MSS with a multi-level structure for monitoring and diagnosing complex technical objects play a key role in ensuring and rehabilitating and continue of critical infrastructure facilities. The purpose of this work is to present a game theoretical approach to analyzing and function of a decision subsystems that operate on a cyclical monitoring and maintenance principle. This approach allows us to investigate the probability structure of the moment routers of the service device in the system, take into account delays in monitoring, diagnostic and data transmission, and provides the selection of the optimal management strategy based on polyharmonic analysis and a theoretical games approach to performance evaluation. To achieve this goal, the following scientific tasks must be solved. Analysis method for predicting the development for unregulated states and decision the residual resource for complex technical system. Formalize the task of selection and multi-level monitoring and diagnostic systems. Operate strategy use the placement matrix method, which takes into account the probable scenarios of object states. Implement and an approach to selection of optimal strategy, use game theory methods and optimize objects. The relevance of forecasting in multi-level monitoring and diagnostic system is determined by need to forecast the load at the system input based on data from all objects of man-made systems, as well as to assess the remaining resource of a specific complex technical object is in an unregulated state. Given the cyclical nature of technologies operations and the seasonality of the phenomena caused by change in natural cycles, temperature regime, and weather conditions, the most adequate models for forecasting in the intensity of the input flow of requests at the multi-level monitoring and diagnostic system. Input and model expression 1. That refines the goal forecast model 1 is supplement with the forecast of the random component, which is generalized based on the autoregression equation. Formalization, the task of selection and multi-level monitoring and diagnostic system strategy allowed reducing into a game theory task in which the strategy random sets of characteristics of an unregulated states and the decision-making subsystem section its own optimal strategy for restoring the state of object. Strategy of selection model in presents using the M multiply M payment matrix C. The rows of the matrix correspond to multi-level monitoring and diagnostic system strategies, and the columns correspond the predicted intentions of unregulated state of the delta T period. Criterion for selection of the optimal strategy, the selection of strategy S below Captain S is made taking into account the conditions of each task, for example, based on the maximum efficient or minimum costs, taking into account the following expression for. The study found that the dynamic of the development of unregulated states of complex technical objects can be effectively described using polynomial models of varying degrees of complexity. Formalization of the process of selection, the multi-level monitoring and diagnostic system function strategy using the payment matrix method made it possible to structure the decision space and take into account the economics affection of each the alternatives.